Hello and welcome to the second video on logarithms. In the previous video we saw what happens to log of a powered term. So here log of x to the power k is the same as k times the log of x. So we can see that the power k can be brought down to the front and multiply at the front, so you get k times the log of x to base a. We also looked at if you do log of a to the same base, then the answer will always be 1. And if you do log of 1 to base a, then the answer is always 0. So in other words, log of 1 will be 0 to any base. In this lesson, we're going to look at two more rules of logarithms, the multiplication rule and the division rule. If you're looking at the log of x times y, this is going to be the same as the log of x plus the log of y to the same base a. And the log of x divided by y is the same as the log of x take away the log of y to the same base a. Okay, let's move on to applying the laws of logarithms on some questions. Question 1, write as a single log term. So here we have a log of 5 plus the log of 4. Okay, so when we're plussing two log terms together, we multiply them inside the bracket. Now you can see here that the base of each log is not written. What that means is that both logs are to the same base, so we can do this without writing down the base numbers. So this will give you the same as the log of 5 times 4 inside the bracket, which simplifies to the log of 20, and that's written as a single log term. For the second one, 2 times the log of 6 take away log of 9. So let's simplify the 2 times the log of 6. So we saw in the previous video that the coefficient of a log term can move to the top as a power, or it can be moved back down as a coefficient. In this case, in order for me to bring the two logs together using the laws of logarithms, this power 2 needs to be brought back at the top. So the coefficient of each of my log term needs to be 1. So if we do that, we would get log of 6 squared minus the log of 9. Now using the division law of logarithms, that's the same as 6 squared divided by 9. So that's the log of 36 over 9. That simplifies to log of 4, and we have our single log term. So now let's move on to solving equations using the laws of logarithms. So here we have 2 to the power of 4x equals to 3. Now in this equation, the x is the actual power itself. X is on the index at the top. So we can't really work out what x is unless we can bring the x back down as a coefficient, and then maybe we can solve the equation. And you saw that earlier in the previous video, in order to bring the power down, we have to apply a log. So in this case, if we apply a log to both sides of this equation, so let's say we have apply log on the left side, which is log of 2 to the power 4x, we will have to do the log on the right side of the equation as well, so we get log of 3. Now it's up to us what base we can pick for each of our log, but it makes sense in this case on the left hand side that we do log to base 2. The reason for that is because the term here has a base number of 2, and having the log to base 2, those two bases will cancel off, and in which case this will leave us with just 4x equals to, on the right side we also apply the log to base 2, in which case the log of 3 to base 2 doesn't cancel off, it stays as it is, and we can just write this as log of 3 to base 2. And finally, to find what x is, we just divide by 4, or it would be a quarter of the log of 3 to base 2. And all we have to do now is plug this into a calculator, and this will give you an answer to 3 significant figures if you need to write the answer to 3SF. So on to the second question on solving equations. We have the log of 4 to base 10 plus 2 times the log of x to base 10 equals to 2. Now in this equation, the unknown x is inside the log. Okay, so we can't really get to the x itself unless somehow we can get rid of the log from each of those terms. And to get rid of the log, we need a single log term. And we saw in the first example how to turn a two-term logs into a single log term by using the laws of logarithms. So first we will need to do something about this coefficient here, because the coefficient has to be 1, so we're allowed to move that to the top as a power, and we can rewrite the equation as log of 4 to base 10 plus the log of x squared to base 10 is now equal to 2. And now we can see that we're adding two log terms together, so that kind of hints towards the multiplication rule, and we can rewrite this as the log of 4 times x squared to base 10 is equal to 2. Now if log of 4 times x squared to base 10 equals 2, what that means is 4x squared will be the same as 10 to the power of 2, which is obviously 100. Therefore x squared would be 100 divided by 4, that gives you 25. So our x would be equal to plus or minus 5. But hang on, but if you go back to the question itself, x is bigger than 0. In other words, x has to be positive. So this means our x can't be a negative number, and the fact that x has to be bigger than 0 means that our x can only be equal to positive 5. Moving on to the next question. So here we have the log of 2 minus 3x. Take away 2 times the log of x equals to 2, and here the logs are given to base 3. Now I think you can do this question yourself because it's similar to the ones above that we just done. So why don't you have a go at this question? So solve the equation to find x, and once you're ready, press play and you can check your answers. Okay, so we are subtracting two log terms together, so obviously we're going to use the division law, but at the moment we can't apply the law unless we get rid of that 2. So the coefficient obviously has to be 1, so we're going to move that coefficient of 2 up to the top, so we end up getting x squared. So on the next line we're going to write the log of 2 minus 3x equals to take away the log of x squared equals to 2, and don't forget the base number was given as 3. So now we have two log terms being subtracted, which means at a single log term they will be dividing. So the log to base 3, and when you're dividing, the numerator is going to be 2 minus 3x, and the denominator of a fraction will be x squared equals to 2. What that means is now if you now undo the log of base 3, this will give you 2 minus 3x over x squared equals to 3 to the power of 2, which is 9. So if you now take the x squared to the other side, you get 2 minus 3x equals to 9x squared, or rearrange into a quadratic, we get 9x squared plus 3x minus 2 equals to 0. And if you factorize this, we get 3x minus 1 multiplied by 3x plus 2 equals to 0. So our solutions are x equals to 1 over 3 or x equals to minus 2 over 3. Now just like before, x has to be greater than 0, otherwise if you look here, this log term here won't be valid because you can't have log of 0, in which case we can cross out the negative solution, so our answer is just going to be 1/3 for this question. Now moving on to the final question. Right, so here we have 5 to the power of z squared minus 9 is equal to 2 to the power of z minus 3. Now here the base numbers are different. On the left side the base is 5 and on the right side the base is 2. That basically means that we can't simply take logs on both sides to get rid of the base numbers, because the base numbers would be different, so you'll only cancel off the base from one side of the equation and not from the other side. So let's cancel the base number from the left hand side. In order to do that, we have to apply log to base 5 of 5 to the power of z squared minus 9, and do the same on the right hand side. It have to be log to base 5 of 2 to the power z minus 3. Now on the left side, because we're doing a log of 5 to base 5, the 5 and the log 5 will cancel off, and that will just leave us with z squared minus 9 equals to, here we have the log of 5, or log to base 5 of 2 to the power z minus 3. We can apply the power rule now. So when you do log of a power term, the power can be brought down to the front as a coefficient. So that gives us a z minus 3 multiplied by the log of 2 to base 5. And this can be seen as a bracket which can be expanded. So the left side is z squared minus 9 equals, and if we expand the right side of this bracket, we will get log of 2 to base 5 multiplied by z, subtract 3 times the log of 2 to base 5, and if we bring everything across to the left hand side, we get z squared minus log of 2 to base 5 times by z, and then we have plus 3 log of 2 to base 5 subtract 9. All of that is equal to 0. And if you look here carefully, you can see that this is actually a quadratic equation where a is equal to 1, b is equal to your minus log 2 to base 5, and c is basically those two terms together. So here a is equal to 1, b is equal to minus the log of 2 to base 5, and c is equal to 3 log of 2 to base 5 subtract 9. All we have to do now is plug these into your quadratic formula, or use the special built-in function in your calculators, and this will give you the answers for z. You will get z equals to 3 and z equals to minus 2.569 dot dot dot. So in this equation, you can see that within the equation itself, there are no restriction on z. I mean, we can have z as positive or we can have z as negatives. Therefore, the solutions we have are basically z equals 3 and z equals to minus 2.67 to 3 significant figures will be the two solutions to this equation. Hope you have enjoyed this lesson, and I'll see you in the next video.